In this figure, L is parallel to N. Jesse listed the first two steps in the proof that shows that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. Meaning 1 plus 2 plus 3 is 180 degrees. Meaning it's a triangle, right? It says L is parallel to this, and these two lines are parallel to one another. Step. Angle 2 is congruent to angle 4. Angle 2 and 4 are congruent, and the question is why? Well, if this is parallel, then this is my house, right? And then you can extend this line. And the question is, why is this 2 and 4? Why are they equal? They're both inside, so it's interior, and then they're on opposite sides of the transversal, so that's alternate. So interior, alternate. So that's the justification for that. Number 2, y is 3 and 5. 3 and 5. That's the same thing. You can see my z's. They're inside my house and they're alternate. So I'm looking for alternate interior angles are congruent, which is A. All right, the points O, -4, 3, A, x, y, and B, x3 create a right triangle inside of circle O. Point A lies on the circle. OA is 6 centimeters. What is the equation of circle O? So circle O, it says points O, which is the center, because that's how, when you say circle O, you're calling it by the center. So point O is going to be -4 and 3. A is somewhere. A lies on the circle, so A is on the circle somewhere. So let's say A is over here. And the distance between O and A is 6. So what's the other word for that? That's a radius, right? All right, and then it creates a right triangle with wherever this B is. It doesn't tell us where B is, but it's not on the circle. So I'm going to put B over here outside. I just know that it's a right triangle because it says creates a right triangle. So this is B somewhere out there, and that's x3. A is xy. All right, what is the equation for circle O? So the equation of a circle, remember, you can find that in your formula sheet. And it is where? Oh, right here. Equation of a circle. So you write that down, because that's the information I need. X minus h squared plus y minus k squared is equal to the radius squared. So what I need is the center. So I need the center. And I need the radius. So that's kind of easy. So the center is, yeah, that's kind of easy. Wow. All right, the center is this. So that's hk. So let's go ahead and put that in. X minus h is -4. So -4 squared plus y minus k is +3 squared equals the radius, which is 6 squared. All right, go ahead and fix my smiley face. So x plus 4 squared plus y minus 3 squared equals 6 squared, which is 36. And that would give me 36 is this one, x plus 4, x minus 3, option D. So honestly, this question, they just throw in a whole bunch of rubbish, really. That was a really easy question. So just because a question looks complicated, don't feel like, oh my God, oh my God. Just read it through and go through it, because that question ended up being really simple. All right, in this circle, the measure of arc QR, the measure of this arc is 72 degrees, okay? What is Q, the measure of Q, angle QPR, what is this? Okay, so do you remember the relationship in the circles? So I will do this. To the center is the same, and all the way to the end and inscribed is half of that. So 72 divided by 2 will give you QPR. So that's 36 degrees. Look at the square pyramid, okay? If the plane of the figure is parallel to the base of the pyramid, which best describes the shape of the intersection? If the plane of the figure is parallel to the base of the pyramid, which best describes the shape of the intersection? It's a square pyramid, so it's going to be a square. If the plane of the figure is parallel to the base of the pyramid, okay, so whatever figure this is, okay, which best describes, I guess the word is best. Okay, so what is closest to a square between all of these options? It's going to have to be a rectangle, right? That's the closest thing that I have to a square because it's a square pyramid, meaning the base, if you look at what shape it makes, it should be a square, but it's close to a rectangle.
Item 5.
This diagram shows two ladders leaning against the building. Each ladder is leaning at an angle of 70 degrees. The length of the short one is 8. The base of the long ladder is 5 feet further from the base of the building than the base of where the short one is. So in other words, whatever it is here, it's 5 feet more, okay? What is the length of the nearest foot of the longer ladder? So this is what I'm looking for, question mark.
All right.
I'm assuming there's no calculator because they're giving you
Options. On this one, you're not allowed to use a calculator.
so what can I do? What can I do? All right, so let's do this. Oh, you are allowed to use a calculator, just not a scientific one. All right, let me find how far this is from here to here. The reason being, if I find this distance here, I can use similar triangles to compare this to this. You see what I mean? So let me find that first. So this is actually a good question of how they're putting two things together. So let's say I'm looking for this. This is X. I'm going to label this triangle on the side here so that it's a little bit bigger. So this is 70. That's my 90. That's X. That's 8. Okay, let's label. So that's opposite. That's hypotenuse. And that's adjacent. Okay, so what do I need? H and A. All right, so H and A, so cosine. So cosine of 70 is equal to A, which is X, over H, which is 8. When the number is on the bottom, all you do is you just move it to the front. So it's going to be 8 cosine 70 is equal to X. And they're telling you that cosine 70 is 0.3424. So it's 8 times, and you're using the number they give you so that you get the correct answer, is X. So you're just going to punch that into a calculator. 8 times 0.3420. So you're going to get 2.736. So X is equal to 2.736. All right, so 2.736. All right, so now let's compare. This goes with this, and this goes with that. Or you can say that goes with that, and that goes with that. Doesn't matter where you start as long as the order stays the same, right? So question mark goes with, or you could say question mark goes with 5 and 8 goes with X. Question, you can do, actually you do the big triangle. Question mark goes with this whole thing, and 8 goes with this little piece. So I'm just going to compare let me do it that way. So question mark, big triangle, okay, goes with little triangle. And then big triangle on the bottom, so 5 plus 2.736, so that's going to be 7.736, goes with little triangle on the bottom, which is 2.736. All right, cross multiply and divide, so you're going to get 2.736 question mark equals 8 times 7.736. Then divide both sides by that 2.736, so that goes away. And just put that in the calculator to find my question mark. So it's going to be 8 times 7.736 equals divided by 2.736 equals 22.61. 22.61. And rounding it to the nearest foot, so no numbers have decimal. What's that 6 going to do? It's going to make it go up, so question mark is 23. I'm pretty sure if you compare this, we'll just stop there. All right, item 6, look at the coordinate grid below. What is the perimeter of PQR? Okay, so you have to find all the sides, right? So let's start with the easy one. A horizontal distance, you can just count that. 1, 2, 3, 4, so that's 4. You can use distance formula or Pythagorean theorem to find it. I'm just going to plug it in into the distance formula because I have a calculator, and the calculator is easy, and I don't have to explain that much. So here's the distance formula, so I'm going to write that down. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and I'm going to find the distance between Q and R. So distance between Q and R. So Q is 0, 2. R is 1, negative 2. I'm also going to find the distance between P and Q. So the distance between P and Q. P is negative 3, negative 2. And Q is 0, 2. All right, and I wrote it all out because I'm just going to punch in the calculator. I'm just going to label x1, y1, x2, y2. Doesn't matter what order as long as your 1s are together and your 2s are together. x1, y1, x2, y2. All right, so
All I'm going to do now is punch those in.
into this formula. So it says the square root. And you see, because there's square roots in the answer, I'm going to leave my square roots in my answer too. So in other words, what I'm saying is it'll be equals to square root. I'm not going to put the square root in there. So you see how it says square root? I'm going to put that in my answer, so I'm not going to put that in the calculator. I'm just going to start with the parentheses. So parentheses, x2. So looking on this first one, x2, 1, minus x1, 0, close parentheses, squared, plus y2, negative 2, minus y1, positive 2, so minus 2, close parentheses, squared.
Enter.
17. So I'm just going to put that, so square root of 17. Same thing here. x2, so open parentheses, x2, 0, minus x1, negative 3, close parentheses, squared, open, plus, open parentheses, y2, 2, minus y1, negative 2. All right, now, in a calculator, you have to fix these signs. Actually, I should have thought of that before I did all this. But anyway, close parentheses, let me finish. Close parentheses, squared. If I do that, it's going to give me, it actually gives me the answer. Oh, I thought I had to fix it. Oh, perfect, 25. So then I'm going to check. Can I take the square root of 17 with it giving me a whole number? No. What about 25? I can. It'll give me 5. So this one is 5. So PQ, P to Q is 5, and then this other one is square root of 17. To find the perimeter, you add them all together. So 5 plus 4 is 9, and then plus square root of 17. So we have 9 plus the square root of 17. Just see. Look at the coordinates of a square, ABCD. What is the perimeter of the square, ABCD? So perimeter, so if you had a square, A, B, C, D, it's a square. Do I need to find all of them? No, I just need to find one because it'll be the same. So let's find the distance here between A and B. So using these coordinates, we're going to punch it into the distance formula again. So write the distance formula down, square root of x squared, x2 minus x1 squared plus y2 minus y1 squared from the formula sheet. And then you're just plugging it in. So I'm going to label x1, y1, x2, y2. And again, your order doesn't matter which one you choose to be 1 and 2, as long as the 1s are together and the 2s are together.
All right, then you're going to take the calculator.
All right, and then you're going to do, and I'm going to leave it in, because I can see square roots in my answer, I'm going to leave it square root in my answer, just in case, because I don't want to type it in twice if it's wrong, if it's not a whole number. So open parentheses, x2. x2 is 2 minus x1. x1 is negative 3. Close parentheses, squared, plus y2. y2 is 4 minus y1, which is 0, close parentheses, squared. So make sure it reads just like it should. Enter 41.
The distance is 41.
Okay, if I take the square root of that, it's not going to give me a whole number, so I'm going to leave it like that. So what it's saying is that this is the square root of 41, 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 because it's a square. All the sides are congruent. The perimeter is when you add all of those together. Okay, so if I add the square root of 41 plus the square root, it's really times it by 4, isn't it? Because there are 4 of them, but anyway, I guess I can just do this. Plus the square root of 41 plus the square root of 41. How many square root of 41s are there? 4. So if I just do 4 times the square root of 41, I'll get my answer. But you can also do it that way. You get a decimal, right? I know it's 4 times the square root of 41, and I'm just going to prove that to you by saying 4 times the square root of 41, and you'll see that it gives you the exact same answer. So if you're unsure, you could do it with the decimal and then check these answers by plugging them in to see which one matches. All right, Paul has a spinner with the colors red, green, blue, orange, and purple on it. He also has a 6-number cube. The probability of the arrow in the spinner on green is 1/5. The probability of getting a number greater than 2 and tossing a number cube is 4/6. What is the probability of landing on green? And means we're going to do what? We're going to multiply. Tossing a number greater than 2. So what's the probability of landing on green? The probability of it landing on green is 1/5. And multiply, tossing a number greater than 2. Probability of tossing a number greater than 2 is 4/6. Put that in a calculator. So 1 divided by 5 times 4 divided by 6. And then if you do math, enter, it'll give you a fraction back, so 2/15. If you don't have a calculator that does that, you can just plug in all of these and see which one gives you the same decimal.
All right, number 9.
All right, triangle ABC is similar but not congruent. So what does the word similar mean? Same shape, same angles, and sides are what? Proportional. Where congruent is, the sides would also be the same. Okay. Which series of transformations would map ABC onto triangle DEF? Okay, so ABC is similar but not congruent, which means whatever we're doing in here, I need it to dilate because I need it to get bigger or smaller because I need the sides to be proportional, not congruent. All right, so translation 4 units, there's no dilation there, so it's not that. Reflection across the line, rotation, there's no dilation there, so it's not that. Translation 3 units left, dilation of scale factor of 2 centered at the origin, that could be true. Let me see what else is there. Reflection across the x equals y reflection, so there's no translation there, so it has to be that one. All right, which equation must be true about triangle ABC and triangle DEF? Which equation must be true? So remember, the sides are the same shape, same angles, the sides are not equal to each other. They're proportional. So the sides can't be equal to each other. So it can't be that. The sides cannot be equal to each other. All right. Triangle. Now let me just draw a triangle. It doesn't matter what it is. So I can just see. Measure of angle A and draw triangle DEF. So remember, I guess I should draw it bigger or smaller, right? So let's draw it smaller. DEF, let's say it got smaller. Doesn't matter. I just need the letters. All right, so angle A plus angle B is going to be angle D plus angle it should be angle E, right? The same one. It's not going to be angle F, so it's not that one. Angle A, I'm just using side because I already have marks, plus angle C has to be D plus angle E, D plus angle F, sorry. And that's true, so it's that one. Okay, so even though you don't really know what happened to the triangle, it doesn't matter. You just needed to know what the definition of similar and congruent is. All right, triangle GHJ is a right triangle. Angle G has a measure of small g, angle H has a measure of small h, and angle J is a right angle. So I'm going to actually draw that. J is a right angle, so J is where the right angle is. Okay, so GHJ. So this is a small angle, and they said G has a measure of G, H has a small measure of H. Okay. Select two equations that must be true. So you have to select two of them. Sine H is sine G. No. So remember, with that, I already know where this must be going. The sine of angle G is the cosine of angle H, or vice versa. Okay? Complementary angles. So sine H is the same as sine G. That's not going to be true. Cosine G, if we're doing cosine G, we have to do sine H, which is true. So that's a true one. Cosine H and cosine G. No, they can't be, cosine can't be the same on both of them. All right, sine H plus cosine H. So, okay. Then the other ones have to be cosine G plus sine H. Because you have to do the complementary, so that's not true. Sine G, so this other side has to have cosine G. Okay, good. Plus cosine H, this other side has to have sine H. That's correct. So that one. Because sine G is equal to cosine H, or cosine H is equal to sine G. All right, part B. Given the tangent is sine over cosine, which ratio must have the value equivalent to the tangent of G? So again, sine G is also the same as cosine H. So I can say this can be cosine H, and cosine of G will be the same as sine of H. So it's the same. That's what I'm looking for, I'm sure. Cosine and sine, no, cosine H, sine H. That's what I'm looking for. I'm just going to check this one again because it says I have the wrong answer here. So let me look at this because it says the answer on this one should be B and D. So let me look at this one. All right, sine H. So I should have cosine G. I do. Okay. Plus cosine H. So I should have sine H. Oh, no, I should have sine of G. I'm tripping. Okay. So sorry, D was the right answer there. So sine G, I'm just going to write it down. Sine G, so I should have on this side cosine H plus cosine H, that I should have sine H, which is I don't. Okay, so I made a mistake over there. I'm sorry, my bad. So the answer is B and D. All right, number 11, the figure shows the tangent lines QR. Now, I know automatically, when I hear tangent lines, I know the radius and the tangent lines must make a 90-degree angle. I just know that. I have to fill it in before I even finish reading. And SR. So the radius is right here, and the tangent line, they make a 90. Okay, so that's the rule. So whenever you have the radius and the tangent line, it always makes a 90. Okay. All right, so I'm filling that in as I'm reading. The measure of Q, the angle QCS, so there is X. Select three statements that are true about this figure. So this is a quadrilateral, right? So this already is 360 minus 90 minus another 90. So 360 minus 180 is 180. So I know that X plus this has to be 180, if I need that. But anyway, let me read the answers and see what's up. The measure, so how many? Three statements. I need three. The measure of angle QPS is 90 minus x. All right, so let's see. Give me a second so I can see how to get that. I don't know how they would get 90 minus x, because I would need to know what QS is. I would need to know what this is, or even what this is. QPS. Actually, you know what? Because I know this is x, the arc is x, right? And then this, the inscribed angle is always half of the central angle or half of the arc measure. So this PQS should be a half of x. So not 90 minus x, so it's not A. The measure of QPS is a half, oh, and that's what I just did, right? So that one's right. The measure of PSR is 90. I've got my 90 marked in there, so that's right. The measure of CQR is 90. Perfect, and I got that one in there. So those are my 3 statements. So I don't need the rest. So those are wrong, those are wrong. It's saying, though, that this is PSR. Oh, no, I'm tripping. Look, guys, PSR is not just this 90, it's also including this little bit, so that's not right. So I have to still keep reading. All right, the measure of QRS, all right, is 180 minus x. That makes sense, because this, okay, if this is a quadrilateral, right? So the whole thing is 360. Minus the 180 is 180 left. So this plus this has to be 180. So to find this, if I did 180 minus whatever this is, I would get that. So E would also be right. So BDE. The measure of QRS is twice of x. No, it's not. The arc measure is twice x.
That's why you shouldn't work in pen, by the way. I'm just saying.
All right, Billy's created a circular garden divided into 8 equal sections. The diameter of the garden is 12 feet. So the radius, if the diameter is 12, the radius is 6. So each one of these is 6. What is the area in square feet of one section of the garden? So what is the area of this? And that's what kind of thing? It's the area of a sector, and that's in your formula sheet. So
Area of a sector of a circle is that.
So you just write it down. Oh, it says what? Explain how you determined your answer. Okay, so
Anything along the lines of,
well, I'm just going to do it, and then I'm going to tell you how I determined it. So in my answer, I would need to say, I found the radius, and
I'm not writing this down. I'm just going to say it.
I found the radius of the garden to be 6 feet because I divided
The diameter by 2 to find the radius.
So that whole explanation, okay, so that's how I got 6. Then I used the area of a sector, which is equal to, and that part I'm going to write. So I skipped all those lines where I explained all that. And then I said area of a sector, which is equal to pi r squared theta over 360. And I plugged, and you see I'm writing, and I plugged in r for the radius. And each angle, okay, so then each of these angles, so the whole thing is what? 360, right? And they're divided into 8 equal sections. So to find one section, I'm going to do 360 divided by 8 to find a section of 45. So this is 45. Okay, so then I found the measure of the angle for each sector is 45 because I divided 360 into 8 equal measures of 45. And then I used that to plug it into the area of a circle, and I got 6 squared, and then this is 45 over 360. Tripping. And then you just plug all that into a calculator. Do they want left pi? Use pi as 3.14. Okay, so pi is 3.14 times 6 squared, which is 36, times 45 divided by 360. So 14.13. Okay, so now let me tell you that whole explanation. So you would be writing this, okay? So let me say that whole explanation again. All right. Given the diameter is 12, I found the radius to be 6. because the radius is half the diameter. Given that it is split, the garden is split into 8 equal sectors, I determined the angle of each sector to be 45 because the whole thing would be 360, and there are 8 of them, so 360 divided by 8 would give me each side be 45. See, I'm writing this down, okay? And then I used the area of a sector, which is equal to pi r squared theta over 360, and plugged in the radius and the angle to find 14.13. So any explanation around that area, but you'd actually have to write out the words, not just show this. If you showed this, you probably wouldn't even maybe get half a point or something. So if it's like 2 points, maybe you get half a point because you didn't explain it. Okay, so make sure that you actually explain it. All right, number 13. Jane and Mark build ramps to their remote control cars. Both ramps are right triangle when viewed from the side. The incline of Jane's ramp makes a 30-degree angle. So here's a ramp. 30-degree angle with the ground. The length of the inclined ramp is 14 inches. So the ramp is 14 inches. The incline of Mark's ramp is 45 with the ground, and the length of the inclined ramp is 10 inches. Part A, what is the horizontal length of the base of each ramp? So what's X, what's Y? Explain how you found your answers. Write your answers in the lines provided. So you draw that. Okay. I'm first going to do it, and then I'm going to tell you what to write down. So let's do it. So what's that? That's O, that's H, that's A. So this one I want A and H. Okay, same thing. That's O, that's H, that's A. That one I want that. All right, so Katoa, I need A and H, which is cosine. So cosine of the angle, which is 30, cosine of 30 is equal to adjacent, which is X, over hypotenuse, which is 14. On this one, I guess I can do this first. Move the number there, so that's 14 cosine 30 equals X. Punch that in the calculator. And you're going to use what they tell you. So cosine 30 is that. So 14, 0.8660. All right. And then this one, still A and H. So cosine of 45 is equal to A, which is Y, over H, which is 10. So take the number to the front. So that's going to be 10 cosine 45 equals Y. And cosine of 45 is 0.7071. All right, so let's just put those in the calculator. So 14 times 0.8660, which is, so X is 12.124. And over here, 10 times 0.7071. So Y is 7.071. All right, now you got to explain all of that in words, okay? So the question is, what is the horizontal length of the base of each ramp? Explain how you found your answers. Write your answers in the line provided. Okay, so I've written my answers, right? Now I'm just going to explain it. I first drew a representation. So this is my explanation, right, that I'm writing in words. I drew a representation of the triangles described in the question. I then used the angle for both Jane and what's the other guy's name? Mark. I used the angle, went across from it, and labeled that opposite. I used the 90-degree angle, went across from that, and labeled it hypotenuse. And whatever was left over, I labeled it adjacent for both triangles. I then used the formulas provided. I then used the formula for cosine is adjacent over hypotenuse, and I plugged in the angles and the numbers. The angles and the sides, I'm sorry. Once I had my equation set up, I multiplied both sides by the number, by the side lengths. So in, who's this first one? 30. Jane. So in Jane's case, my equation became 14 cosine 30. And in Mark's case, my equation became 10 cosine 45. I then used the numbers given for cosine of 30 and cosine 45 to put it in the calculator to multiply to get a final answer for Jane of 12.124 and for Mark 7.071. So that's it in explanation. So you do the work, but you have to say it in words. Like, like how I teach you every day and just tell you what to do, that is what you have to write down. So some kind of variation of what's happening here. If you just do this, you don't get the credit, okay? It's a lot of work and you don't get the credit. You have to put in the explanation. Maybe they give you half the credit, so maybe they give you 1 point instead of 2. You explaining is what gives you the second point. Okay, so big thing, anytime you see these lines or whatever, do the work, but you also have to type it in, okay? All right, and is that it? Yep, that's pretty much it.